Next week.
What?
Next week. Next week. It's a short week this week and a short week next week, so we're combining them. We're doing a super quiz on Friday next week. Yeah, no pandas for you guys. That's right, buddy.
Is he?
Yeah, he is.
Notification squad.
I'm watching the stream.
Should I tell my mom?
Sorry.
Yeah, he's got like a whole group. But I'm gonna tell him to come watch.
Oh, do it. Do it.
I'm watching live.
Alrighty, it's time to do the duel. Alright, so here we go.
I did my
Really?
Please be proud of me.
5, 6, 7? Oh, I'm proud.
I did 5 and 6, I think. I didn't know how to do 7. Oh, wait.
2, 3.
I did 7.
5, 6, 7, here we go. So the weird part about 5 and 7 is that we have negative numbers for B, right?
Correct. I need a pen.
That was a great round.
Another one.
Oh my god. I can't beat him. He's too good.
You gotta shoot it up. One more.
I'm running out. Oh! It's complete. All right. So, here we go. 5, 6, and 7. All right. So, again, the weird thing about 5 and 7 is that there's negative B values. And by B values, I mean that letter, that number right there next to regular X.
The letter B.
The letter B, number B. Yes. They're negative, which means we have to be careful. We're talking about the dimensions of the square. So let's talk about it. Talk about it. I'm going to do the square thing just for the first one. Hopefully you'll catch the rest better than Schlaffer. Not Schlaffer. What am I doing? Shamba. It's the CH. That's what I get there. The SCH. Hope you do better than Shambody with catching it. All right. So this is number 5.
Yeah, we already went over.
Did we do it 5 together? We did? Oh, I thought I had it for homework. So we need to look at number 7. 7's a weird one. 6 and 8?
No.
6, 7, 8. That's what it was. 6, 7, 8. Yeah, I wouldn't have made you do 8. It was 6 and 7.
Yeah, it was 6 and 7.
All right, there we go. Kobe. Let's do 7 real quick. Okay, this is 7. Y equals, if you were absent yesterday, this would be a great time to pay attention. So we got this. Remember, what this represents is we have a square, right? Let me do, let's do all markers. I've been doing too much pens lately with geometry. So we have a square that is x by x, right? And that represents x squared, because that's the area of that square. And then we are going to add on, and I know it says minus, but we're going to add on a rectangle that has dimensions of -6 and x, right? Now we're going to split that rectangle in half, and that allows us to do this. So we're splitting this rectangle, this guy right here, and we're sticking it on top and on the side. Now, when we split that rectangle in half, what are the dimensions of the rectangle going to be again? What by x?
6 by x.
When I split it in half, what would it be?
Oh, 3 by x.
3, but we also have to remember the negative, right? All right. Landry, you know your quizzes, right?
Yep.
All right, cool. So we have dimensions of -3 by x. And of course, these sides are x because that's x, right? Cool. You'll notice that we have a missing piece to complete a perfect square, right? And that piece is what we're going to add to both sides of the equation. Now, what are the dimensions of that yellow piece right there? Let me zoom in. What are the dimensions of that yellow piece? Well, they've got to be -3 by -3, right? Because this has a length of -3. And so this is going to also have a length of -3. And when we write that in there, it is very important that you think of it as -3 quantity squared, right? You have to wrap that in parentheses, and that's going to be important later on. So now we know that the completed square would have dimensions of x minus 3 by x minus 3. And of course it's the same, right? It's a square, right? So those are the dimensions. So another way to write that is to say that x squared minus 6x plus -3 squared, all of that, right? And that's what we did here, right? We had x squared, we had area of negative 3x, area of negative 3x, and we're adding it with this, right? If we add all those pieces together, that's what this is, right? I just combine the negative 3x's to negative 6x. All of that together makes a perfect square. That is x minus 3 times x minus 3, right? That's the area of that square. Another way to write that, of course, is to write this. So all of that will become this. That's why we did it, so we could make that a perfect square. Something squared. So what I'm going to do is I'm going to take the original equation. Remember that plus 5 just stays on the side, right? We're not worried about that. And what I'm going to add to both sides, again, we always add, because we're adding in a square, right? What I'm going to add to both sides is the quantity of negative 3 squared. Do we see where I got that from? So that's the thing I had to add on. This is the original equation, Jace. It's x squared minus 6x, right? The plus 5 we save for later, okay? But notice to make this a complete square, I had to add on this. What's the dimensions of that? Well, if this is negative 3 by x, and this is negative 3 by x, that length is negative 3, so that length should be negative 3. And that's negative 3, so that should be negative 3. So this is a negative 3 square, right? The area is quantity of negative 3 squared. So I had to add that on, right, to the original parts. And that makes a perfect square. What are the dimensions of the new square? X minus 3 by x minus 3, or x minus 3 squared. So all that makes a perfect square. That's going to be x minus 3 squared. Okay? So all of this, we said, makes a perfect square, right? That has dimensions x minus 3 by x minus 3, otherwise known as x minus 3 quantity squared, right? Cool. Then we have a plus 5. Now, to get that in there, because I had to add on more to the equation, I had to balance it by doing it to the side. Now, we're always adding, even though there's a minus, because we're adding on a square. We're adding on more stuff. So we're going to add, right, on what it is. 9, right? And then we get y equals quantity of x minus 3 squared. When we subtract 9, we get negative 4. And that should be the answer. Is that what you guys got for 7? Yes. Rad. Yeah. No, you don't. But I want you to know why this is. Will I ask you on the quiz, explain how to complete the square? Oh, I will, right? Yeah, I'll give you an example problem, and I'll say explain completing the square. And that's what we're going to do right now, okay? So, yeah, I can do 6. It's really easy. Let's do that really quick, right? We split the boxes in half. What's the dimensions of the square that I'm going to add? It's going to be 2 by 2, right? So I'm going to add on 2 squared, right, to both sides. So I get y plus 4 over here equals x plus 2 quantity squared, right? And that takes care of everything. I don't even have any extra. And now I just subtract 4. Right? All good? For number 10, number 6. Ta-da! And that has a vertex at what? Negative 4, right? Cool. So now we know how to get from standard to vertex, right? Vertex standard, just do this in reverse, right? Write that out as x plus 2 times x plus 2, distribute, right? Cool. Let's talk about a general form of the equation. So when we mean general, we mean not with specific numbers, okay? So what we're going to have is parameters. Remember, the difference between a parameter and a variable is like x and y. They apply to the coordinate plane, right? Parameters are things that are like a, b, and c. Usually those are the things we use for parameters. They're really just fancy variables. There's no difference in them. Just the way we talk about them is different. So here's a general equation. Let's get the general form of standard form. Y equals ax squared plus bx plus c. And these are our parameters, a, b, and c. X and y are variables, right? They're going to apply to our coordinate plane and where things are, the coordinates, right? A, b, and c is going to adjust how the parabola looks, right? C is going to be the vertical value where it's up and down. A, we know, makes it wider or thinner. We don't really know what b does yet, though. We haven't really experimented with that. Okay. So, to explain completing the square, I can use this general equation to show you what you do. And then whatever a, b, and c are, you plug those in for your equation that you're dealing with. So, let's talk about it. So, what do you do first to complete the square? Well, you think about what this means, right? Now, we're going to ignore a for now, because we've been doing it without a. Okay? We take half of b, right? So we have a square that's x by x. Right? And then we do half of b. So b over 2, right? Whatever b is divided by 2. That's the dimensions there. And then we add on our square. Now, what will the dimensions of this square be? B over 2 by b over 2. Which means its area will be what? B over 2 squared. Or b squared over 4. Right? Whatever you want. Right? So that means the equation that we're going to write. What are the dimensions of this square? X plus b over 2 by x plus b over 2. Right? So that means our form is going to be y equals x plus bx plus b over 2 squared, right? And then plus c. Now we know all of that should become a perfect square, right? And that'll become x plus b over 2 quantity squared. Now we're missing one thing. What are we missing? Well, we don't have a because I took that out for now. But what else are we missing from here to here? Well, I just randomly added on something to this equation. I can't do that. I have to add it to both sides, right? So what happens is we get y equals x plus b over 2 quantity squared. And then we move that over. Now, isn't b and c, aren't they just going to be a number? Right? They're going to produce some other value, right? We'll call it d, right? That's going to be some number, and we're subtracting it from this number, some number d. Cool? So in general, you take b and divide it by 2, and you make it this. Then you find out what d is by adding it to both sides. Okay? So another way to write d, you can think of it as c minus b over 2 squared. So the general form would be y equals x plus b over 2 squared plus c minus b over 2 squared. Now let's try this out with an actual equation. Let's try the one we just did. So let's do y equals x squared minus 12x plus 46. Actually, we didn't do that one. We did y equals x squared minus 6x plus 5. Right? What's our b in this situation? Negative 6, right? B is the number in front of x, right? And c is what? 5. So we should be able to plug b and c into this and get the right answer. Now we know the right answer. We did it earlier, right? Let's see what we get. Y equals x plus negative 6 over 2 quantity squared plus c minus b over 2 quantity squared. Right? I'm just plugging the numbers in. You with me there?
How do you say one thing and write it different? I couldn't.
Did I say something differently?
No, you said like B and C. And
Oh, well, b is negative 6 and c is 5.
Yeah, but I would end up like writing B.
I'm real good. All right, so what's negative 6 divided by 2? What's negative 6 divided by 2? Squared is 9. 5 minus 9 is? Right. So you don't have to do this every single time, right? You can kind of know the algorithm. We're going to cut that number in half, and we're going to stick it on both sides, right? It's going to go in here, and then we're going to combine it with c by subtraction, right? We're going to stick that number in here, and then we're going to subtract it from c. Stick the regular version in here, stick the squared version on the outside. Could you memorize that? Sure. But it makes sense, right? That's what we end up doing. All right, let's talk about number 8. Well, the directions say, use the information provided to write the vertex form equation of each parabola. All right, we need vertex form. What form is that in? We've called that up till now what? What have we called it? X-intercept form, right? Because we're going to have an x-intercept at negative 5 and negative 4, right? If we were to graph this, I don't know what the parabola looks like. I know it's going to go up and upward, right? And I know it's going to have an intercept at negative 5 and negative 4, meaning my parabola is going to go through those points, right? How do I know that? Because when I plug in negative 4, I get 0, right? The whole thing becomes 0. So I should have a point at negative 4, 0. That's right there. If I plug in negative 5, the whole thing becomes 0. So of course I'm going to have a point at negative 5, 0. Right? So those are my x-intercepts. Make sense? Cool. And again, it's going to open upward. But I need to know where the vertex is. Now, you might think, oh, look, I can just find the middle. And you'd be sort of right. Or you distribute and get in standard form, and then go from standard form to vertex, right? Let's do that. Somebody read me the problem we're on. Quantity of what? X plus 5 times the quantity of x plus 4. Right? Let's get into standard form. So, if I had a 5 here, you distribute the 5, right? Right? Okay. If I had an x here, wouldn't you distribute the x? If I have both, you would distribute both. That's it. So the x, just like the 5, would get distributed, right? And the 5, just like the x, would get distributed. That's it. That's it. We don't need to memorize first, outer, inner, last, and all that crap. If someone says FOIL to you, what they mean is this. I don't like teaching FOIL. I think it's way too complicated. This is called distribution, just like you've always done. It just has 2 numbers. Whoa. We don't use bad words in here. All right, so let's distribute the x first, because that's going to get me x squared, and I want that out front. I just like it in that order, right? So let's do x squared, and then x. If he throws it back, I'm throwing it at you. All right, x to 4. What's that? X times 4. 4x, and then 5 times x is going to get me another x term, and I can combine those, right? So I have 4x and 5x. How many x's is that? 9 x's. That's a lot of x's. Happy Valentine's. 5 goes to x, and we did that already. What's 5 times 4? 20. We're in standard form. Let's use our algorithm. Let's use it. Let's do it. All right. B divided by 2. What's b divided by 2? Or b is 9, right? Let's go with that. Let's go with that. B is 9. 9 over 2 will be the half, right? And then c is 20, right? So our algorithm says this. Y equals quantity of x minus b over 2 quantity squared plus c minus b over 2 quantity squared. Right? That's the formula. Do you like the formula? Probably not.
No.
Probably not. I would rather do it this way. I wouldn't draw the square, but I'd just do what we had been doing before, right? But let's do it. Let's do it just for fun. Just for fun. It's for fun.
Okay.
It's for fun.
We understand.
We're gonna do it, but we're gonna do it
For fun.
for fun. Jace.
Where does the B or the C come from?
B is the parameter in front of x, and c is always this. This is standard form, right? And this is when a is 1, right?
Yeah.
B is 9, c is 20. And we cut that in half, right? We cut the rectangle in half, right?
Yeah.
So we cut this in half. We put it on both sides. It used to be over here, but I moved it over.
Sort of, yeah.
Sort of? Okay, yeah. Parker. Yes, you may. Yes, you may. Parker's a good kid. Works hard. Good kid. Bye. All right. So we do math. Quantity of x minus 9 squared. What's 9 over 2 squared? Whoa, 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 whoa.
I didn't know you were right.
Sorry. What's 9 over 2 squared?
9 over 2 squared.
81 over 4, right? Because 9 over 2 times 9 over 2 is 81 over 4, right? You with me there? We square the top and the bottom. Why? Because we do 9 times 9 and 2 times 2, right? Get 81 over 4. Now, how many quarters are in 20?
Not even.
How many quarters are in 1? 4 quarters, right? How many quarters are in 5 then? 20 quarters. 20 quarters. How many quarters will be in 20? 80 quarters. Is 80 divided by 420? Yeah, so we didn't change the math. We just made it look different. Nice. It's funny. He said the weed number. All right. So that's a negative a quarter. No one tell Preston he's pure. All right. So we're done. That's it.
Whoa. That means it's all this out.
Yay!
Yeah.
What's wrong with this problem? Why couldn't we solve
Can we
it?
please do that?
What the heck, Mitchell? Give me that.
Yeah, what the heck, Mitchell?
What the heck?
What the heck, Richard?
Oh, I changed that mine so much.
It's Michael.
I got that.
Yo, Michael, what day is it? What day is it, Michael? Michael, what day is it?
Oh my god.
Number 9 on your own.
Forgot.
Number 9 on your own. Get it in the standard form, and then we'll do it together from standard to Vertex. Number 9 on your own.
Leave him. Leave him.
No, don't do it. Good job.
Pressure. Leave him.
Number 9 on your own. A.
What did we talk about the assembly? Do you know?
Blood.
Oh yeah. I don't understand why you give blood.
Yeah, go.
It's so stupid.
Get it in the standard form. Go.
Whoa.
Whoa, get it in the standard. It's okay. Go with your instinct, Luke.
Wait, is this what we do?
Yeah, it's a joke.
I'm like to know from the
Well, couldn't you distribute,
I drew the smiley face with banana.
right? And then get y on its own, and then it's in Vertex. Ish, sort of.
It's kind of sort of getting there.
What?
It's negative 7 squared.
Well, it's the same thing as 7 squared, right?
14.
49. That was embarrassing.
Okay, I'm maybe
7 on a square. It's going to have a perimeter of 28.
No, it's 49. Yeah, okay, I'm sorry. I'm tired. I took this.
It's okay, it's okay. No Lindsay today.
She's 6. Hold on.
Oh, was I?
Wait. Is it 20 minutes?
Is it a vent? What is it? I'll show you.
Well, don't be dealing in my class.
What the heck, Richard?
This is what I knew. He had something in his lip.
Knew it.
My keto diet.
Oh, don't do that. And keep the other, you know.
Just cause.
Also, I take back what I said. Get it in a Vertex form. Go fully into Vertex form. Super easy. All right, hold on. Sit down. Get out of the way. Guys, doesn't Vertex form have a quantity of x squared?
Yes.
So why touch that?
I don't know.
It's beautiful.
It's beautiful. Don't touch it. All right, so distribute this, right? And then get it in Vertex form. Move your stuff over. Vertex form is y equals quantity of x something, right? And a bunch of junk left over. All you have to do is mess with the left side.
It's super easy.
My
Getting in standard is actually harder.
gums hurt.
So that's it right now. I don't know.
Ah!
Look at this.
You saw the cat. What? Buddy.
Give the times everything. Like everything. Okay, good. Oh, I see what you're doing. If you're gonna make a note like that, you don't have to do this option. You don't know. What you can do is be like, use I use brackets. I want you guys not to be afraid of parentheses. I had a math teacher that's very afraid of them, and I feel like parentheses are very good for organization. Okay. So it's already almost in Vertex form. All you got to do is mess with the left side.
Couldn't we just multiply it by 1? No, that would make it back to what it was still half.
You can distribute,
Multiply by 2.
or you multiply everything by 2. Because what happens when you multiply this side by 2? What's 2 times a half? 1. So it just becomes this, and we don't even need the parentheses anymore. And we multiply this side by 2. And since we don't need the parentheses here, because it's just addition, right? We can just subtract 4. Did anybody see the big brain play there? Don't even need to distribute.
Yeah, I.
Good
said
job.
that.
I did it the other way.
What'd you do? You distributed? Okay, that's going to make more work for you. Okay, so check this out. Jordan, look at this. Without distribution. Demery times both sides by 2. Gets rid of the half, right? And then she subtracted 4. Way simpler. Now, what Preston did is what Jordan did. Preston distributed the half and got half y. What is half of 4? Because remember when we do multiplication, we say of. What's half of 4? 1. Blast off! All right. But now look what we have to do. Right? We got to multiply by 2 anyway. So why not just do it from the beginning? Yeah, it's okay. It's okay. It's okay. It's okay. Now, when you multiply by 2, we have how many terms over here? Technically 2 terms, right? So both have to be multiplied by 2. So we're going to get 2 times the quantity of x minus 7 squared and minus 4. Right? 2 terms. Nope, you can do it this way too. I don't hear Jay's talk often, but when I do hear him talk about not math, it is always funny. It is always funny. Like, what is going on? I never hear Logan talk. Who's Logan? What?
Hey, do you have Snapchat?
What even is talking? All right. No. Good. 10. I see what you're doing. I know what you're doing.
What are we doing?
You're counting down from 10. You're trying to get me. I almost said it. I'm not going to say it.
What's happening?
He was trying to get me to say the B-O word, and I'm not going to say it.
Boy?
Blast off.
Thank you.
All right. What form are we really close to being in?
That one.
Standard, right? Yeah, go ahead. Standard. So if we want to get into Vertex, probably the best way to do is get in standard first, and then do our thing, right? Do it on your own. On your own. Watch out for the negative 12x that you're going to have, right? Make sure you wrap those parentheses. That's right. I think you need to, whenever you plug something in, no matter where you plug it in, you need to wrap it in parentheses. That is what I say. Now, sometimes I know what's going to happen, so I don't wrap it myself. But I'm a professional. You guys are learning.
What or where or why?
I will erase all of this, and everyone will hate you if you can't focus.
Erase it all.
I'm not here to teach reading.
Erase it all.
Erase it all. That Indian guy.
What's tomorrow going to be?
I'm not in charge of this. This is completely
Who is
gratis.
it? Who's Chelsea?
First hour. I don't know who Chelsea is. She's not a favorite.
Juice WRLD hasn't released a new song yet.
I think that's Charlie or something. Like they were talking about it.
I just got tickets.
I see nobody doing this stuff.
I'm sorry.
I forgot my paper.
Sorry, Deborah. I can get you paper.
I don't want paper though. I don't want to do this.
Why? You can staple it and turn it in, and you have to.
I think I got a paper.
Yeah, standard. That's what I would do, and then get into Vertex.
Can I just solve the problems?
Here, have some more.
Someone's voice cracking up.
Okay, what is this? What are we supposed to do? Can I have a marker, please?
Hey. Okay. 8.
We're wrapping it up.
Ask first.
Can I have a marker?
Yes.
Hey, can I grab your
Any of
phone?
these
really touch you?
Wait, what company? What is happening? Stop over.
This is not consensual. I don't consent to this.
Let's hold it.
That's okay, you don't have to.
Or not.
Hey, I have a question.
That's obnoxious, and I would totally do that.
Do I have to keep the 0 here?
Nope, you don't have to.
Yeah.
Now notice you've got negative y.
Put that away. Put that away.
Really excited.
All right, I'm gonna beat you to it.
No way.
I'm gonna stop though before vertex form. I'm gonna get it to standard. Guys, a lot of you are subtracting y and then multiply by -1. That's fine. You could also move everything over, right?
Yeah.
Either way, you're gonna get the same answer. I'm gonna leave the y and move everything else. When I move it, I either do addition or subtraction, right? I want to move that term and that term and that term. In all cases, I'm going to subtract, right? I don't want to separate the 6 from the x squared. I want to separate the 12, right? I just want to move them all together. Now, we've got a problem. We've got a as -6, right? And that's going to throw things off.
Yes.
So, we can pull out a -6 from these two. So here's what I'm going to do. When I pull out, it's like division, right? Except I don't do it to both sides because I've already got this here. It's undoing distribution, right? I don't have to do that to both sides. So I've got this. It's going to be positive when I pull out a -6, and I get plus 2x. Now, I can't pull it out at the 13, but that's fine. I don't care about the 13. Remember, that's extra bits. So I'm just going to keep it outside the parentheses. Now, I've got a problem we know how to solve, right? So I'm going to solve it in the parentheses. Make sure I keep it in there. So y equals -6. I pulled out a 6 from both of these. That's like division, right? It's undoing distribution. So if I put this back, right, I distribute, right? It's undoing distribution. It's like pulling it out, right? Some of them are. All right. So this right here. Half of this is 1, right? So we're going to need to add on 1 to here to complete it. So it's going to be x plus 1 squared. And then I add on 1 to this side. But here's the problem. If I put a 1 in here, because that's what we needed to add, right? All right, guys, this is the key, so shut up. I need to put a 1 in here to complete the square, right? But I didn't really put a 1. What did I actually put in? A -6, right? So I need to subtract 6 to even it out. Do you see that? Because when I distribute, it'll be a -6. So I've got this, and I've still got that -6 over here. Now what am I going to do with the 6? -6. Add it on over. Now, this is not a hard thing to do.
It's not for everybody.
Right? But some of you guys are going to forget to do it, right? It's a very dumb thing to get wrong. But you will. It'll be a silly mistake that you make. So I know that that's the rectangle. So I cut it in half. My square will be 1 by 1, which is 1 squared, right? And then notice that 1 squared is really -6. Okay? Yeah. So if I had an equation just like this, Logan, to complete the square, I'd have to cut the rectangle in half, right? And that'd be 1, which means the square that I have to add is 1 squared, right? Now I do it to both sides, but here's the problem. I didn't really just add 1, right? Because that's what 1 squared is. I actually added -6. You see what I'm saying? So I have to do a -6 over here to even it out. Cool? That's the big thing. That's the catch. So, do you see how this works? Now, we earlier came up with an algorithm. This thing. And it worked for when A was 1, right? When we ignored A. We found a way to do it without A. If you see how this works now, I want you to develop an algorithm for when A is in the equation. So what I want you to do is get this into vertex form. Get this into vertex form. A's there now. Now notice, what do we do with A, right? We pull it out, which is kind of like division, right? How would we do this? We will end up doing that, yeah, won't we? Right? We will. That's a good point. How do we pull out a from this, right? Right? It's not, we don't have numbers to do it to, right? -6 pulling it out, oh, that becomes this and that becomes that, right? But we don't have numbers, so how do we show that? How do we show this? Well, it should go back, right? So once we guys, shut up. Once we distribute A, it should go back to this, right? How do we show pulling out A when we have B here instead, right? We don't have a number. Before it was like, look, there's 12. I can pull out 6 from that. It becomes a 2, right? But I can't do that with letters. So how do I show that? Not divide by 2, but divide by what? By A. Now we can check that. If I were to distribute, would I get bx back? I would, because A divided by A is 1, times B is B, so we get bx. If I were to distribute it back, I would get this. So pulling out is division, right? But we don't do it to both sides because we already have the multiplication here. So it's already canceled. You see how that's already undoing itself? It's like we did nothing. We didn't change anything. Okay. So we don't need to do it to both sides. And then we leave C on the outside, right? Now, let's complete the square. How do I complete something like this? Well, earlier we said we divided by 2, right? So I got to divide by 2. So what am I going to write? What do we need to add to complete the square?
What you doing there, Preston?
Guys?
What are you doing?
So before, what we did, turn it off, get rid of it. So, before, what we did is we pulled out a 6 from everything, right? We got this. We showed that. We pulled out A from everything. Okay? Stay with me. Gentlemen in the back, you're going to be lost on this. And I'm going to have you do this on a quiz. So we pulled out A before, right? And that made this a 1 and this a negative or a positive 2, right? With letters, you can't do that, though. So what we had to do is we had to show it by division, right? When we pull out A from B, we get B over A. Does that make sense? So now we're here, and we want to complete the square. Well, before we took this number and we divided it by 2, right? And that'll be the dimensions of the square we add, right? So what we're going to add is B over 2A squared. Does that make sense? B over A divided by 2. Division happens on the bottom. We cool with that? Okay. So that's going to go there. Now, we can't just add that to one side of the equation. We got to add it to the other. But what did we actually add? Well, we didn't really add b over 2a squared. We have to factor in that a, right? So if I multiply by a, doesn't the a in the bottom go away? So what I really added was b over 2 squared. You with me on that? Actually, hold on. Hear me out. When we square it, don't we get b squared over 4a squared? Right? So when we multiply by a, only one of the a's goes away. Does that make sense? You with me on that? So this is what we really added. We added b squared over 4a. Almost led you astray there. Are you with me on that? When is everybody up with me to here, right? I pulled out a from everything. It became x squared. It became b over a. You with me on that? Jordan? Okay, put the phone down and I can help. If I pull out a from everything, it's like division, right? I pull it out here. I pull out a from b. I can't do that because I don't have numbers. But remember, it's like division. So I've divided by a. Jordan, if I were to distribute back, I get ax squared, right? And if I distribute back, I have a divided by a, which is 1, bx. So if I were to distribute back, I would get bx, wouldn't I? Because it would get rid of the divides by a, right? So I'm going backwards. I'm going from here to here. Do you agree with me that when I distribute the a, I would get bx? Okay. So what I did is I pulled out A from B, and the way I did that, it's kind of like division, right? So I did B over A here to pull out A from the B. I pulled out the A from the B. I pulled it out from the X, and it got X squared. There wasn't an A here, so I had to divide by A. See how when I divide by A here, I get X squared? Okay. And see how when I divide by A, I get B over A? That's what allowed me to pull that A out. Better? A little? And then we said, now it's time to complete the square. Normally, don't we cut the rectangle in half? And that's the dimensions of our square. So this number cut in half and squared. See where the 2 came from? Okay, cool. Now, we didn't just add that. We added this times A, right? Because remember, we have to factor that in now, right? So isn't B over 2A, B squared over 4A squared, right? Well, when I factor that A back in, it gets rid of one of the A's, right, in the bottom. So what I have to add is this. Better? Not crystal, but better? Okay. All right, we're back. So this is a perfect square. What will the dimensions of that new perfect square be? X plus what? This guy in there, right? Last thing, the formula will be y equals a times the quantity of x plus b over 2a plus c minus b squared over 4a. Does anybody remember from algebra last year the quadratic formula?
No.
Negative b plus or minus square root b squared minus 4ac all over 2a?
No.
You never learned a song?
No.
Good. We're not going to learn a song in here. That's stupid. We're going to come up with it, though. The quadratic formula is something that tells you what the x's will be for any single quadratic you have. So if I were to write a quadratic like this, I could plug in a, b, and c to my formula, and it would tell me what x is equal. Okay? That's what that is. We're going to come up with the formula. I need you to be comfortable with this before I get into that. I'm not going to show you the formula. We're going to come up with it. Okay? Just like the original mathematicians, the OGs. The original geometers. What? Yes. I want to make sure that you guys understand this bit down here. I know you can do it with numbers. Can you do it with letters? You're going to have to explain why things work. Okay? And I want this. We pull out a from everything. We cut the rectangle in half, and we square it and add it to both sides. We factor in that a is going to affect that. So instead of b squared over 4a squared, it's going to be b squared over 4 single a, right? Because that a gets rid of one of the a's in the bottom. Then we subtract. I don't expect you to master it now, but I need a little bit more effort because at the end of a class period, I should be able to expect that you master it. So I need more effort in class, guys. This is by far my weakest algebra class I've ever had. And it's not because you guys are dummies. It's because you guys just don't focus the whole time. And that's okay. Preston. But I know you can be a lot better. My geometry kids are going to graduate as gods. By the time they get out of that class, they will be masters of geometry. Not just for a high schooler, but in general. There will be problems that are not, there will be no problem that's too hard to throw at them. I want you guys to be like that when it comes to algebra. Because algebra, unfortunately, is way more important than geometry. I used to teach calculus, and I would tell my students, calculus easy, algebra hard. Meaning that we'd be able to do the calculus part of the problem. Easy, no big deal. But the algebra, they'd be like, oh my God, I don't know how to move things around, right? You need to know this crap if you're going to take another math class. If you're in my geometry class next year, and guess what? All you are. It will kick your butt. I will eat you up and spit you out. Every day, the geometry kids come in here, and their brains hurt at the end of it. But they're really freaking good at what they do. No pun intended, my geometry kids can run circles around other geometry classes.
I know, I've seen it.
They really can. And you will next year too. But you've had me for algebra, so it's fair game. You'll be working harder than them.
Really?
Know your craft.
Is this your first time doing algebra?
No, I've taught algebra before. First time doing it here. Right, because I'm new. Do it. Do it.
Will you be here next year?
That's the plan, yeah. I want to be. I love this school.
Logan, hit me again. Throwing it.
Ah! Carotid. He's dead. Do it. Don't even need to see. Yeah, go. Next week we got a quiz. Buckle up. Next Friday.
Right in
Over
the
this and more.
Mr. Mack, I'm sorry. I didn't mean to hit you in your face.
I'll take you guys down to the assembly. You guys hang tight. Hang tight. We'll wait for the bell. Oh yeah, go to the homeroom and drop your stuff off. Maybe. Go to your locker. I'm not. Wait for the bell. Wait for the bell. Wait for the bell.
Please leave, please.
No. Go, go, go.
Go, 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 go.
No. Go, go, go. See you at assembly. Is your day better, Autumn? I'm sorry. Let me know how I can help. asked who?
Huh?
Who'd you ask?
Ryan.
Who?
Mr. Vertex.
Oh.
And I was thinking about pushing my luck and saying,
Yeah.
I was gonna ask, can I donate blood if my doctor didn't feel like using scissors on an infant? And he's like, nope.
Take a swapper.
Not to, wait, say it again. It has to be for class.
Oh, I forgot my code in here.
I have nothing to do.
I have actually, May was giving me answers from the test.
Or she was always doing that.
I'm good.
Wait, everyone gets an A+ in that class. Oh wait.
It's because May's fucking genius.
Hey! Why are you here?
Me?
Yeah, that's
Actually, I failed to put 1 and 2. So I have to retake those.
Well, make sure you do your reflections as well.
Huh?
Reflections by Sunday at noon.
Yeah, I got those.
I
Don't
didn't
worry.
do anything.
Sunday and
Do you grade? Have you graded?
Me either.
All of them?
I graded one of them. I don't think I graded the other.
This is a
I did
spine
not.
scoliosis.
No, I didn't. After we speak about
Where are you going? Oh,
Oh, I gotta show some more. Give me a second.
I'm not sure can I do it or not.
Got it.
I don't
Believe in
know.
you.
I have
Do
nothing
that.
to do now.
Oh, I made a big mistake, Mr. Mac. I didn't think that I would have to do any self-development.
2 hours of sleep and a what every day?
2 hours of sleep and a Bang, like the energy drink.
Oh, okay.
Go for it. I put things that I'm stressed about. I put chronic herpes. That's what's in the green.
Brian's the
And
cheater.
from
It's
med school.
Brian, sorry.
I hate math.
so many complaints.
From who? Your mom? Those aren't complaints, those are jokes. You turn your complaint and you make it into a
Things
joke.
we are stressed
No, she wasn't there, but I did
I
show
put
Mark
the, I did the,
scoliosis
I did
fine.
the green. You told me I didn't get anywhere. Oh, you're just. Oh.
Well, Mac, Bartos, only Bartos was there, but I was able to show him the scoliosis spine.
Well, congrats. All
Well,
right.
Big Mac, what'd you think?
I thought it was great. This or what? What are we talking about?
Scooby Doo.
Scooby Doo? Was that your voice?
Yes.
I was surprised to know it was you. Alright. Who's Shaggy? Who is Shaggy?
That was Colton Sage. Horrible Shaggy. I had to coach him.
Yeah, you really do need to coach that guy. That guy was the worst. Scooby was good.
Oh, of course it was.
Alright, welcome back.
Como te llamas? No, what is welcome? What's namaste mean? Does that mean welcome?
No, no mas means no more.
That's, I'm talking about, I'm speaking an Asian language. It's like namaste.
Namaste.
Oh, namaste. What's that mean?
That's Indian, I believe, because it's.
India's in Asia, isn't it?
This is true. But
Metaphorically.
Mexico's in North America.
Yeah, and they don't speak American, so. Oh my god.
Mr. Mac, a teacher yelled at me because I was running in the hallways.
Yeah, that would make sense.
I sit down in the assembly and Parker's 2 rows behind me.
That's not a good
I didn't know he was behind me, and all I hear, he whispers in my ear, he's like, Bernie Sanders sexually assaulted somebody.
Mark, why are you here? Step on that with me, just get fucking out.
Once again, asking.
Get out!
What about the other test
Okay,
You don't get to
review
take-
that usually, or no, you don't.
Mac,
That's
I
what-
need my review.
Shut up,
It was one
Andrew.
with the 5
Self-independence.
I got like the last two.
I have the
Which one or
coronavirus
quiz two?
instrument.
2.
Alright, I will print off a version 2 for you right now.
Okay. But like I got like the first 3 like right. I just need to. Can I just do like the last 2?
Yeah, you want me to do the ones you missed?
All right.
Mac is 1 and 2.
I will do that right now.
Are you sleep deprived again, Mac?
It's not a joke.
Why do
Okay.
you invite all these?
Some people have it.
What?
What?
Coronavirus
No.
or herpes? Chronic herpes.
Alright.
Well, he's dead.
Geometry.
You bang every day. People piss me off.